Hi guys, let's take a look at this question where we have a heavy object that is lifted using 2 ropes and 2 pulleys, and it's shown in this diagram below. The 2 pulleys are at a distance x apart. There we have x. The force Fa of rope A is 730 Newton, so this is rope A, and the force of rope B, so this is rope B, is 1440 Newtons. Rope A makes an angle of 70 degrees with the horizontal, so there's the angle there, and rope B makes an angle of 10 degrees with the vertical. Define the term resultant vector. So a resultant vector is the sum of 2 or more vectors. Okay. 2.2. Explain why the vector diagram of force A, force B, and the weight will not be a closed vector diagram. This is because the object is being lifted, or the resultant force is not equal to 0. 7.3. Calculate the vertical component of Fa and the horizontal component. So they want this component here, but they also want that component. Okay, so our vertical component is Fy, and let me just put the question number. So vertical component is Fy, horizontal component is Fx. Okay, so we have Fa. This is vertical, so we use sine and the angle of 70. You put that into the calculator. You put 730, that's the force of A, and you put sine 70. Plot in the calculator and you get 685,98 newtons. Then for the horizontal component, we have the same force, but here we use cos of 70. So again, you have 730 and now you have cos of 70. You jot that into the calculator and you get 249,67 newtons. 2.4. Calculate the maximum weight that force A and force B will be able to lift from the ground. Show all calculations. Okay, so I'll do it on the side here. 2.4. All right. So we can calculate the vertical component of FB. So we say sin of 80. Or you could have said the vertical component is cos of 10. Maybe that makes more sense for some of you, but because this is a 90-degree angle, you can use 80 and 10. Okay, but let's use the second one, right? So it is 1440, which was given here, the force of FB, and we say cos of 10 because we have been given that, right? So let's just use it, and that gives us 1418,12 newtons. Sorry for that noise, guys. That was just my pen flicking across the room. Okay, too hard at work here. All right, what do they want? They want the maximum weight that force A and B will be able to lift. So now we have calculated the vertical component of force B, right? So the maximum would then be the vertical component of force A and the vertical component of force B. We've calculated both. So there is the vertical component of force A and there is the vertical component of force B. We just add them together. I'll just rewrite it. You jot that in your calculator and you get 2,104,1 newtons. Easy peasy. So that's what the force will have to be able to lift the object from the ground. Last question. Explain why the rope and pulley system will be less effective if the distance x between the pulley is increased, because if the distance increases, the vertical components of the applied forces will decrease, and thus the system will not be able to pick up the weight of that object. All right, guys. Hope that made sense.